Hello, good afternoon everyone. Welcome to the class ECE341, the probability and the stochastic process. Today we will study Gaussian distribution, normal distribution, but with multiple variables, okay? More than one variables. We already have the Gaussian distribution with one random variable. We will study the case we have more than one variable case. ECE341. This is for the 10th week Wednesday's class. So we will consider the varied normal distribution or Gaussian distribution, the same thing. All right. Here the notation is we write in this way. Capital X obey a normal distribution with a mu and a sigma. Here x equal to x1 until x sum n. Each xi is a random variable for each I run from 1 to until n. So this is a vector. We put all these x1 to xn together as a vector. We have this capital X. Each capital X1 to capital Xn, they are random variables. And here mu is also a vector. It is mu1 to un. This is a vector of constant. Vector of constant. This one is a vector of random variables. This is a vector of constant. And the sigma, it is a matrix. Sigma 1, 1 until sigma 1n, the first row, and the second row until the nth row. It is an m by n square matrix, and we suppose this one is positive definite. Okay, here we have these matrix vectors, positive definite. They are concepts coming from the linear algebra. So if you forgot, then you need to go back to have a review. But here we only need some very basic things related with matrix and vectors. All right. Okay, we say X obey a normal distribution with this mu and sigma. That means we have the PDF of x is fx of x equal to, it is 1 over square root of, here's a 2 pi times 2 pi to the nth times the determinant of sigma. Right. This is a constant before the exponential power. Then we have exponential power of, inside is 1 over 2 with a negative, and the times, this is x minus mu transpose times inverse matrix of the sigma, and times x minus mu. Right, is this one. This is a density function where capital X we already have, right? Capital X is this one. This lowercase x is what? Where this lowercase x is x1 until xn. Alright. it's a capital N, that's a lowercase n, capital N. Okay, sorry. Capital N. It's capital N. It's also capital N. Capital N. Okay, so X is this one. So this is PDF. This is PDF. The definition just look like this. Okay, for this one we have some good feature, some properties. We say properties of normal distribution. The first one, we have these, right? Here x is x1 to xn. Then we can have those average values. You see, xi, take mean value, that is just the mu I. Yeah. Mu I. Mu is here. Mu is here. So EXI is just mu I. And the variance of xi is sigma I. The element at the ith row, ith column of sigma give us the variance. And let me see, we have this one, we have this one, and the second thing, we have the covariance of xi, xj equal to the element of this sigma at ith row and j's column. Yeah, suppose I do not equal to j. If they are same, that is variance. Same, if they are same, they are variance. Okay, so we have these two features. That means these vector mu and these matrix sigma give us almost all those average values, right? And of course, we do not have the third one, the R, xi, xj. Now, which one? Which is by definition, it is the expectation value of xi times xj, right? This one. This one equal to what? Okay, this one, we have formula like this. We know covariance of xi, xj are equal to E of xi, xj minus exi times exj. Right? We have this formula. And this is R. This is just R of xi. This is R xi, xj. Right. So this one, it is a covariance plus this. So this one will equal to the covariance. This is covariance, right? This is covariance. Covariance plus this one. This is a mu I, mu j. Okay. So if you want to calculate any kind of average values, you can just use this formula. Do we have any more? Okay, we have another one about the correlation coefficient, rho xi, xj, which will be covariance is this one, ij, right? This is covariance over sigma. Sigma is this one, right? Over square root of sigma I times square root of sigma jj. Now we also have this form. Alright. Okay, this is one feature about how to calculate those average values based on this mu and sigma. This is one thing. Okay. I say this is A. Property A. In the property A, we have 4 different formulas. And the second part is B. Say it's B. Now say for any numbers. I say alpha 1, alpha 2 to alpha n and a beta. Let y equal to alpha 1 x1 plus alpha 2 x2 plus until alpha n, capital N, alpha n xn and plus beta. Then y is also a normal random variable. Alright, this is also Gaussian. It's also normal, also Gaussian. And we have E of y equal to alpha 1 mu 1 plus alpha 2 mu 2 plus alpha n mu n plus beta. And the variance of y or equal to, we need to write this way, alpha 1, alpha 2 until alpha n, this is row vector, times that's sigma, this is square matrix, and times column vector, alpha 1, alpha 2 until alpha n, equal to this. Alright, so we can also find the variance of it. And we know this is normal distribution, so when you have the mean, you have the variance, you can have the density function, right? The PDF, probability density function. Alright. What else? Later, for the now we're working on the control part, in the probability part, and then the other part is the statistic part. In statistic part, we need some work based on the normal distribution with multiple variables, so we need this kind of formula. And I think maybe we need one more formula. I just put it here. For another random variable z equal to, now is beta 1 x1 plus beta 2 x2 plus beta n xn. I already used alpha beta. Okay, let me make a change. I do this as not a beta. I use a q. Okay, use a q. So here's a q. Right. And this is this one plus p. Okay, if z is a random variable, combine those x with coefficient beta and plus a constant p, then we will have z is also Gaussian. Right, similar with y. So we also have this one, we have this one, and that y, z, they are joined Gaussian. This is one thing. Second thing is the covariance of y and z. Actually, for the mean and the variance of y and z, we already have these formulas. We can just apply those formulas. We can have them. But for covariance, we need a new formula. The covariance of these y and z, it will be this one: alpha 1, alpha 2 until alpha n. These are the coefficient from here, right? Alpha 1 to alpha n times that matrix is sigma, and times alpha Oh, z should be beta. It's a beta 1, beta 2, until beta n. Now we have formula looks like this. Alright, so another word, y and z, if I put them together, it will obey a normal distribution of mu. Now mu is I can write it shorter. Mu is this one, right? Mu is this one. This one I can write it shorter. This alpha times mu, right? This is alpha times mu, and alpha. No, I have two. N of alpha mu, and the second will be beta mu. And the sigma. Now this sigma will be. This is alpha sigma. Alpha is a transpose. This is a beta transpose sigma beta. And here is a alpha sigma beta. This is also alpha sigma beta. Is it this one? This one. Can we change these? Make it a symbol. Oh, this one I can also write as a beta sigma alpha. Beta sigma alpha. Alright. Okay. So this is the normal distribution with more than one random variables. Now we can study an example. We have x and y. X and y both are random variables. Random variables x and y, they have joined the PDF. It is a f x of x. Actually, this is second order system, so you can also write as fx and y, right? X and y. Okay, just like this. fxy. Here's x and y. We have two random variables, right? X and y. This will be some. Suppose I know this. This is some c times exponential power. Here's a negative. Which number I can choose? Let me think of that. I use negative. Okay, it is x squared over 8 plus x times y minus 1 over 10, and minus, here's a y minus 1 square over here over 18. Okay, like this. Now suppose we have the PDF. Is this one. Okay, now we consider what kind of problem do we have. We have problem. First one, we want to find C. What is this C? Second one, we want to find the PDF of y, which is 3x. Oh, this is y as usual. Z equal to 3x plus 2y. I want PDF of this one. And then of course we want to know like the mean of it, mean of z, and the variance of z. Okay, suppose I want to know this. Actually, we can also have more. A, B, C, D. We want to know EX, EY, variance of X, variance of Y, and the covariance of X and Y. Okay, so we want to find this. Now it's 20. Yeah, suppose I will start from here, try to solve them. If I have more time, then I do it. Alright. If no time, I just leave it again. You can try it later after the class. Okay, So first one, we want to find the C. Here you need to observe the original one. What is this one? Actually, this one is a kind of things you can write in this way. So this should be a Gaussian distribution. And then we want to find C. That means you want to find the mu and actually you want to find the matrix. This matrix, right? You want to find this. This is a sigma. Find this capital sigma. If you have capital sigma, you put it here. Then you can have this C this part, right? Okay. Now we compare. Here. This is a given CDF, and this is the CDF of Gaussian distribution. We want they are same for certain matrix here, right? Sigma matrix and certain mu. So you compare these two. How to determine mu and sigma? The thing is, now we want this part equal to this part, right? Now we want 1/2 times x minus mu the transpose times sigma matrix inverse times x minus mu. We want this part equal to this part. This is a negative x squared over 8 plus x times y minus 1 10 and minus y minus 1 squared over 18. Right, we want this. Okay, here we can choose. So mu will equal to just 0 and 1. 0 and 1. This 0 is when you subtract it, it will be x minus 0, right? Okay, this this is a vector where x is this x. I put the bar here. Where x bar equal to x and y. All right. Mu is this one. And what is this? You compare these two. I can write as times 2 to the other side. It is x bar minus mu transpose times sigma inverse times x bar minus mu equal to, I move 2 to the other side, that means I times negative 2 here. Times negative 2, I get x squared over 4 plus x times y minus 1. Here's 5, right? I need times 2 on this side, I get 5. And here's a minus 9. No, this is minus. This is plus. Right? Here's I move compare. I check cancel this negative and this negative. And here's a negative. I move a negative to here. Should be minus, right? And this one will be plus. I times 2 to this side. It will be 9. Here's a y minus 1 squared. So we have this. And this one. Now I try to write it in this way. This one we can work like this. We have a in general one. We have this x1, x2 times a, b, c, c times x1, x2 equal to a times x1 squared plus b times x2 squared and plus 2c x1, x2. So this one, if we multiply and have element, it will be this. You can try if you are interested. Just matrix way to multiply them together. You can have this. All right. Then this one. So this one will equal to this one will equal to, we write in the matrix way, it will be x, this is x, So I have x and y minus 1, actually I have a y minus 1 times, here's a 1/4, 1/9, and half of it, this is 5. 5, I see this is a 10/2, right? 1/5 is 10/2, and I use half of it. So it's a 1/10, here's 1/10, and a negative, and times x and y minus 1. Alright, this one is just this one. You will have x squared times 1/4 and y minus 1 squared times 1/9, and x times these times the first element and the times second element, do summation. So you have the 1/10, 1/10, you add it together is 2/10. 2/10 is 1/5. Right? Okay, so this is sigma. Now we have sigma is, this is sigma inverse, is 1/4, negative 1/10, negative 1/10, 1/9. This is sigma inverse. And the mu were equal to 0, 0 and 1. So we have these two. And then we want to have this one. This one is 1/4, 1/10 with negative, 1/10 with negative, 1/9 with inverse. Okay, now we can calculate. This one equal to 1 over the determinant. This one times this one is 4, 9, 36, and subtract, this is 1/100. Oh, okay. Then here where we flip this element, it's 1/9 and 1/4, and the change sign of these two elements, I have 1/10 and 1/10. Okay, so this is the sigma, and next page. So sigma equal to, this is what it is, 1/36 minus 100. So I can write these as 3600. Here's 100 minus 36, right? And this part is 1/9, 1/10, 1/10, 1/4, and this is 100 minus 36. I have 64, and 3600 in the top, and here is 1/9, 1/10, 1/10, 1/4. Now we have sigma. Okay. All right. When you get sigma, okay, I put it inside. I times them inside. So this is 3600 is 60 square, right? And over 64 is 8 square, and 9 is 3 square, right? And this element I times inside is also 60 square, and 8 square times 2 square is 2 square. And this element, okay, I just times them together. It's just 360 over 64. This is also 360 over 64. Alright, so we have sigma is this one. And then C, what is C? C as a normal distribution. The coefficient before this exponential power should be this part. So now C is just this part. It is 2 pi to the power n. Now is a second order, right? It's a two-dimensional, so this is 2. And the determinant of that sigma and square root 1 over 8. So we have these, right? Just this part. And then we need Yeah, just this part, Then we need to plug in what is the sigma. Okay, what is the determinant of sigma? I can put it here. Determinant of sigma are equal to this one times this one. So I have 60 square and square is 4th over 80 to the 4th times 3 square times 2 square, right? This is this one times this one. Then minus this one times this one. So 360 over 64 times itself. We have determinant of sigma is this number. Oh, this is somehow large. Can we make it this symbol? Oh. Anyway, I just leave it here. 2 pi square times this one is 60 to the power 4th over 8 to the power 4 times 3 2 square and times 2 2 square and minus 360 square over 64 square includes 64. We have these. Okay, so this is a denominator and take square root. It's this one. It is this one. Okay, this is long. We can try use MATLAB to calculate. Okay, MATLAB. It is okay. It will run for a while. Alright. Okay. Then here I want this one, right? I want this number. I want this number. So it is 1 over square root of. Did this work? Square root. Okay, the right function. I just tried. Inside the square root, it will be the square of 2 times pi square. Okay, this is 1, and then times square. I have 1. We have this, right? We have this one. Then times not 2 square and the times inside I have 2. The first one is 60 to the power 4th over 8 to the 4th and over 3 over 3 over 2 over 2. Can I write in this way? Right, I divide it by 2 times and divide by 3 also 2 times. Right, square. Okay, this is the first element, and then let me see. The second element will be this one minus. That is a square. Inside is a 360 over 64. Right? This is 64. Does it work? Oh, it's a very small number. Okay, anyway, it's just this number, I can put it here. It's equal to 3.74 and e to negative 4. So actually this is a 3.64 over 1, 2, 3, 10 fourths, right? 10 fourths. 10 to the fourth, 10 to the fourth, 10 square, cube, fourth. Okay, it's this one. This one is a small number. Small number. Am I good? Yeah, it's fine. It's fine. Okay, so we have C is this one. We have C this one. All right, then let's go back to the problem. We want to find the C, and next we want to find the PDF of Z. Z is 3x plus 2y. Second part B, Z is 3x plus 2y. We want to find this one equal to what? Okay, as we said, this one, because x and y, they are joint Gaussian, so this 3x plus 2y is also Gaussian. And we have Z Bayes Gaussian for some mean, some variance, right? This one. We want to find these two numbers. This number will be E of Z. E of Z equal to E of 3x plus 2y. This will be 3 of EX plus 2 of EY. And EX, as we said, EX related with that mu. This is a problem with a mu. So I got mu is here, 0 and 1, right? Mu is 0 and 1. So this one is 0, this one is 1. So add them together, 3 times 0 plus 2 times 1, I get 2. This is easy. Oh, sorry. It's covered like this. Z is 3x plus 2y. And I want to find the density function of it. As we said, because x and y, they are joint Gaussian, so Z is also Gaussian. Z is also Gaussian. Obey a normal distribution with certain parameters. One determine these two parameters. The first parameter is E of Z. So we calculate, we get 2. Right? EZ is E 3x plus 2y equal to 3x plus 2EY equal to 2. And then variance. Variance of Z now is variance of 3x plus 2y. So this one should be variance of 3x plus variance of 2y plus the 2 of the covariance of 3x and 2y. We can calculate like this. So this is a 9 of variance of x plus 4 of variance of y and 2 of the, okay, I move 3 and 2 in the front. This is the covariance of x and y. Add this. So it's 9 times, what is the variance of x? Because I have this one. So this is the variance of x. This is variance of y. So this is just the variance of x is a 60 square over 8 and 3 both square. So I have 24 square, right? 24 square. And then 4 times variance of y will be this one. This is a 60 square over 2 and 8 is a 16 square. And plus the covariance. Here is a 2, 3, 6. 6 times 2 is 12. And the covariance of xy, it is just this value. So this is 360 over 64. Alright. So this is the variance of z. Variance of z. Can we have the exact value Alright, I still use my lab. Okay. Now is 9 times is 60 square over 24 square. This is the first term. And the second term is 4 times 60 square and over 16 square. Alright, second term. And then plus plus 12 times 360 over 64. Okay, I have these three terms, right? Double check. 9 times 60 square over 24 square plus 4 times 60 square over 16 square plus 12 times 36 over 64. Oh, it's 180. Okay, we have this is 180. Then we know the z obey the normal distribution. Mu is 2 and variance is 180. So sigma will be square root of 180, right? Then we have fz of z. This is a one-dimensional Gaussian distribution. It will be 1 over square root of 2 pi times the sigma, the square times this one, 180. It's just times 180 here, right? You can also move it out, that will be sigma. And then exponential power is -1/2 times, now is a z square, is a z square over, here should be the sigma square. Sigma is this one, so it's sigma square is 180. Okay, so we have the density function of z. Density function of z. Our second question. Yeah, this one. Then the PDF of z is just this one. And then what is the EZ and variance of z? Actually, we already have it, right? EZ. So C EZ is 2 and the variance of z is 180. We already have it. Okay, this is C. And then D. D, I want EX. What is the EX? We look at it. We have this part, right? So EX will be this first element. And now is I get a mu. Oh, sorry, too much pages. This is a same, and I have mu. Mu is here. Mu 0, 1. Mu 0, 1. So EX is a 0, and the EY will be 1. Okay. Okay, I have oh sorry, I forgot it. It's covered. Okay, review this part again. We have the z is the 3x plus 2y is combined of x and y. Then we know z is also a normal random variable, is n of, okay, we need 2 parameters here, and the first parameter is e of z. Then we just do the calculation, we have 2. And then the variance of z, we also do the calculation step by step, right? Z is 3x plus 2y, then separate as 2. Also for variance, when you separate them, you need a covariance here, and each term you do the calculation, you know the value. We already have this variance x, variance y in previous step, right? They are in the matrix sigma, they are part of the matrix sigma. So I put the value here, and then I get 180, and use MATLAB to get this 180. Then we know Z is normal distribution with parameter 2 and 180. 2 and 180. Here 2 is the mean of Z, and 180 the variance of Z. And you can also have the sigma, which is the standard deviation, which is the square root of 180. And we can have the density function, the PDF probability density function, because you know mu and sigma, so just plug in. Here's a sigma square, right? This is sigma square. You know sigma. Here's a sigma square, and here's should Z minus that mu. Now mu is I lost 2. Yeah, correct. This is a Z minus 2 square. Yeah, Z minus 2 square over 180. Alright, then we have this is part B. Then for part C, we have E of Z. Yeah, we are saying this is the mean and the variance, right? Mean and variance. And then for part D, we need EX, EY, and the variance of X, right? Yeah, this one is coming from that matrix. So this element, this is a variance of X, and this one will be variance of Y, right? So you just take the value, put it here, you get it. All right. So variance of X will be this part. So it is 60 over 8 times 3 squared. I can make some simplify. This one I get 20. And then I divide by 4. This is 5. This is 2. So this is 5 over 2 squared. This is 2.5 squared. This will be 625. Okay. So I have variance of X. And we also want the variance of Y, I think. Yeah, variance of Y and covariance of X and Y. I want these two. So the variance X is this one, and the variance of Y, you can also find it from this matrix. So it should be this one element, this element. So it's a 60 over 8 squared. It's a 60 squared over 8 squared times 2 squared. So this is a 60 over 8 over 2 and square. I can cancel something, right? 2 that gets 30. And this is 15, this is 4. So this is a 15 over 4 squared. Alright, this is variance of Y. And then we want the covariance of X and Y. I want these formula. We have the matrix, right? It's here. It's just this one. So it is just 360 over 64. Right? Just this one. 360 over 64. What it is? Can we make some simplify? I divide by 4. I have 90. Right? And here divide by 4, I have 16. 16. And then I can have 8. Here's 45. Can I keep make it more simple? Okay, just like this. Alright. This is covariance. And what else can we have? Yeah, that's all. I put the ABCD here and I have all the results. Alright. Yeah, this is the example. The example is we start from distribution looks like where it is too many pages. Sorry, I have where it is. There's a problem. Where's the problem? This is 0. This is 0. This is it's a problem here. Problem here. If we have a CDF looks like this, then we want to determine C. In other words, we want to make sure what kind of distribution it is, and we'll say it is a Gaussian distribution with mu and sigma. Mu is at 0 and 1, and sigma is that matrix. Yeah, mu is 0 and 1, and sigma is this matrix. Is this matrix, right? Sigma is this matrix. All right. Okay, that's all for today. See you next time. Bye bye.